So this question is a continuation of a prior question. And we have, for perspective, we have the positive direction, the negative direction. That makes this a velocity of +5, that a velocity of -5. They both have the same mass from the question. But we also have the wonderful gift of a graph. So we need to first tackle it with our Oizerga. And so our origin is 0, 0. Y-axis is force. And it goes by 500s. X-axis is time. And it's got, very, very fine time. This goes by 0.001 seconds. The intercept. So there is initially an x-intercept and a y-intercept. So xy at 0. And then we have an x-intercept again when y goes to 0. Over here, we can read force and time. The gradient of the slope is delta F over delta T, which is the rate of change in force. And the area is F times delta T, which is the definition of impulse J. And the impulse J is equal to the change in momentum, which is F delta T, which is M delta V. So we know that X collides with Y and exerts a force. Well, both are in contact with A. Graph of force that object exerts on X exerts on Y is shown. So it's X on Y. So X on Y is in that direction, up there in the picture. How could the graph be used to determine the change in momentum? Well, the change in momentum is about the area. Okay, so multiplying maximum force, which is up here by the time, no. That would be the area of a rectangle, so that's out. Dividing the force by the time, well, we know that is the rate of change in force, so that's out. Determining the magnitude of the slope, well, the slope between 0.5 and after, again, the slope is the rate of change in force. So if we were bold, we would just choose D, but by determining the area bound by the curve in the horizontal axis from 0 to 0.01 seconds. So from 0 to 0.01, that's the entire area. And that's why the answer is choice D.